Alright guys, acyl chlorides and acid anhydrides. These two functional groups come under the carboxylic acids and derivatives topic. So if you're revising that at the moment, this video will contain every single thing you need to know under the AQA A-level specification regarding their reactions. So this text on the screen is taken directly from the spec, okay? And it tells you exactly what you need to know. If you're not using the specification and you really want to go for those A's, A stars, start using it, okay? So by the end of this video, you will know the structures of acid anhydrides, acyl chlorides, as well as amides, okay? Amides are produced in some of the reactions involving these two functional groups, so we'll check that out as well. You will also know the nucleophilic addition-elimination reactions of the acyl chlorides and acid anhydrides, and you need to know their reaction with 4 different substances. So we have water, alcohols, ammonia, and primary amines. So although in this video we're going to be covering the nucleophilic addition-elimination reactions, their reagents, conditions, etc., or everything that's involved, you also need to know the mechanisms, okay, the curly arrow mechanisms, and that will be included in a separate video because there's quite a lot to cover. So let's jump straight into this and look at the structures of the two functional groups. So let's start with acyl chloride over here, and we'll do acid anhydride over here. Okay, cool. So acyl chlorides are really simple. So if you think about your carboxylic acid, okay, let's start with a really easy example. So we have, let's think of ethanoic acid would be like this, okay? Really simple. If you want an acyl chloride, you just replace this hydroxyl group, this OH, with a chloride ion. So it becomes Cl right here, okay? And then depending on which acyl chloride you're working with, this will stay exactly the same. So if I box this up, this will stay the same. This is actually the functional group. It's very similar to a carboxylic acid. The only thing that will change is the length of carbons within the chain. Okay, so in this example is ethan. Okay, and the way that we name this, okay, is the suffix is always going to be oil chloride. Oil chloride. Okay, and then depending on how many carbons are in your chain will determine the first portion. So in this example, it's 2 carbons, right? So it's going to be ethan, ethanoyl chloride. Okay, if we dealt with 4 carbons, it would be butan, then exactly the same suffix, oil chloride. Okay, pretty simple. Practice some questions and you'll be completely fine. So let's rub that out and jump onto our acid anhydrides. So again, because they are carboxylic acid derivatives, they are very similar structures, okay? So as I mentioned, I'm going to be using ethan as our base, so 2 carbons in the chain, and then sort of see what's going on here. So very similar to our first example, let's say you had ethanoic acid, right? How is this going to become an acid anhydride? You simply want to mirror the molecule. So it loses a hydrogen ion here on this hydroxide, and you literally just repeat the molecule and you think of essentially an imaginary mirror here, okay? So if we do that, obviously you don't actually want to draw that mirror in your exam or when you're practicing these structures, you just want to think of it like that in your head. And it would be like this, okay? Now, one thing I haven't done here that you may want to pay attention to in your exam is if you are drawing these bonds, you may want to start with H3C because this bond right here is not on the hydrogen, it's on the carbon. So that's just something to keep in mind. But for the sake of presentation, this is completely fine. So these acid anhydrides, how do we name these? And these are actually even easier to name, guys. So you would have, let's say, for example, we still had our hydrogen here. Let's rub this out. And this was still ethanoic acid, right? So let's draw that out. Ethanoic acid. Now, when it comes on to naming these, super easy. So again, we're turning it into an acid anhydride like this. You literally just keep the first part of the name based on the carbon chain. So it would still be ethanoic. Okay, and instead of ethanoic acid, it just becomes ethanoic anhydride. Okay, simple as that, doesn't get any more complicated. If again, this was like 3 or 4 or 5 carbon chains, you would just change the name accordingly. So if it was 3, it would be propanoic anhydride, 4 would be butanoic anhydride, etc. Okay, hopefully you get the idea there. So structure's done, okay? Now before we move on to the reactions, reagents, conditions, etc. that you need to know under this topic, we have to think about their reactivity, okay? So in both of these functional groups, we have a leaving group that's going to be leaving the molecule throughout the reaction, hence the name, right? So in the acyl chloride, it's going to be the chloride ion, and here it's going to be one of these, okay? So if we write that out then, what are our leaving groups here? Simply going to be Cl for this, and it's going to be the OCOCH3 for this, okay? That's our leaving group here. And it's important to recognize that these two leaving groups are recognized as good leaving groups, okay? That's just what they're referred to as. You don't really need to know why, but the fact that they're good leaving groups makes them far more reactive than carboxylic acids and esters. Okay, so these acyl chlorides and acid anhydrides, they're going to be very reactive. So my objective here for the reaction side of things, because the mechanisms can get a bit messy, I want to summarize it for you as simply and efficiently as possible. So let's do a nice table format to see what's going on. So we're going to start with our starting functional group. Okay, so I'm going to call that start functional group. And this is either going to be an acyl chloride or an acid anhydride. And then we're going to have our reagent. And then we're going to have our end functional group, or in other words, our products. Then we're going to have our conditions. We're going to have our observations. Okay. So let's start with our water reagent. So acyl chloride then, and acid anhydride. What is our reagent going to be here? We've already said it's going to be water. Okay, so let's put H2O in both of these boxes. Next up, what is our end functional group going to be? In each instance, it's going to be a carboxylic acid. Okay, so I'm going to just signify that with RCOOH. This R group right here can essentially be any sort of length of carbon chain. In our structure example, we used ethane, so 2 carbons, okay, including this carbon right here. And we're going to have exactly the same end functional group right here, okay, RCOOH. So what is our condition going to be here? Our condition is going to be room temperature, okay, and that does not change for all 4 of these reactions. So the reaction with water, alcohol, ammonia, and primary amine, none of these conditions change. It's going to be room temp the whole time. Okay, and what is the observation here? So the observation difference with water for the acyl chloride is going to be hydrogen chloride gas. Okay, and this is white steamy fumes. Okay, white steamy fumes of hydrogen chloride gas. Whereas with the acid anhydride, we don't have any observations. And that is how you'll be able to differentiate the two when you react with water, is the acyl chloride will have white steamy fumes of hydrogen chloride gas, and the acid anhydride is not going to have anything going on, okay? You wouldn't see anything. All right, so that's water done. Real quick, let's look at alcohol. So OH group right here. And as always, this can be any alcohol. What is our starting functional group? Exactly the same, either acyl chloride or acid anhydride. What is our end functional group going to be? In this case, it's going to be an ester, okay? Ester can just be thought of as RCOO, okay? So the R can be any sort of carbon chain length, so CH3 for a methyl, CH2, CH3 for ethyl, etc. Okay? And again, going to be the same for our acid anhydride, some sort of ester. I'll actually write that out. I'll actually write out ester for you here, just so you don't get confused with the R's and everything going on. Conditions, again, I'm not going to bother writing this, room temp. Okay, real simple stuff. What is our observation? What's our observation going to be here? Again, hydrogen chloride gas is produced. Okay, so we're going to get white steamy fumes. Exact same thing as when you react with water. Okay, and just as with the first example with water, you're not going to get any observation with the acid anhydride. Okay, real simple stuff here. So that's the first 2 out of the way, real easy stuff, guys. Next one, we're going to be dealing with ammonia. So good old NH3, guys. What is that going to produce? As our end functional group, is going to produce a primary amide. So I'm just going to write that out as 1 degree to denote primary, just like with alcohols and proteins. But in this case, it's going to be amide. And again, exact same thing here, primary amide. Okay. What is our condition? Don't need to say it. It's room temp. Exactly the same for all of them. So what is our observation going to be here? Is it going to be hydrogen chloride gas again? No, it is not. Okay. It's going to be NH4Cl. And this is good old ammonium chloride. Okay. And this same color, it's not steamy fumes, it's smoke this time, way more smoky. So NH4Cl, ammonium chloride, smoke, and poor old acid anhydride is not having a good time. It also doesn't have an observation for this reaction either. It's only going to be the acyl chlorides. And the reason for this, guys, the reason for this is because we have a chloride ion present. That's going to form one of these products here, given off, and it's going to have an observation. With this guy, it's not a happy guy, no chloride ion present, so we don't get an observation. And as we covered in the spec, you need to know the structure of an amide, so I'll go over that shortly after this section. Last reaction then, primary amine. I'm going to switch back to blue here, so primary amine, and again, primary amine. Okay, now, if you haven't done the amine topic, don't worry too much here. I'll go over what a primary amine is right now, actually, just to make things a bit simpler for you. So we have our amine group here, right? NH3, well, ammonia, really. Now, with an amine, you're going to be losing one of the hydrogens, and you're going to be having an NH2. This is the amine functional group. You'll see it in amines, you'll see it in amino acids, etc. Now, when it's primary, you're going to be having one carbon chain like this. Okay, so let's say we had an ethyl group. Okay, this is a primary amine. Now, if we said, you know what, screw this hydrogen, I'm going to get rid of that hydrogen and I'm going to add on another carbon chain, CH2. Let's add another ethyl group. This would now be a secondary amine because there are 2 carbon chains attached. All right, hopefully that makes sense. I'm not going to go over it in any more detail in this video. I'll save that for an amine and amides topic. But for now, that's all you need to know is how many carbon chains are attached. If it's 1, it's primary, 2, secondary, etc. Okay, so let's rub this out and get back to our reactions and see what's going on. What is our end functional group? Our end functional group is going to be a secondary amide. Okay, so what actually is an amide? I'm going to write this here quickly. Secondary amide, exactly the same product for both. What is an amide? Very similar to an amine, okay? So with all of these carboxylic acid derivatives, you're going to be having your backbone structure. So I'm going to be using ethane as our example, right? So for example, like ethanoic acid. You're going to be having your backbone structure. But with amides, you have this right here. So let's say we reacted it with ethanamide. So CH3, CH2, NH2. Okay, this is our primary amine. Now, when this reacts with either our acyl chloride or our acid anhydride, we're going to get the primary amide. So what happens here is we're going to be having this part of the amine bonded on to this part of the carboxylic acid derivative. So we'd have just this part of the carbon chain, we're going to be having NH, CH2, CH3. Now, as I mentioned, every time you go from a primary to a secondary to a tertiary, etc., you're going to be losing one of these hydrogens. So one of these hydrogens is going to go off, and we're going to be left with this product as our example, okay? And that is the basics of amides. So that would be our amide structure here. So what actually is the amide functional group? It's this guy right here, okay? So let's zoom in on this part here so you guys can really understand. Feel free to skip ahead if you're already all good with this. But you'd have your CO bond, you'd have your N here. This is going to trail off onto the rest of the molecule. So R denoting some sort of carbon chain. And then we're going to be having an R group here and then R group here. Okay, normally you see this as R prime, denoting a second carbon chain. Okay, so in our example, the R group right here is just a hydrogen. Okay, and that's because it's a secondary amide. Now you may also see this referred to as an N substituted amide. So let me actually make a note of that here for you guys. N substituted amide. All right, just keep that in mind. You may see it written like this. So lastly then, let's look at our observations. What observations are going on for our reaction with a primary amine? Nothing. Absolutely nothing. Okay, a big fat cross here. So there's no way to differentiate these two in terms of observations when you're reacting with a primary amine and producing a secondary amide. All right, guys, so let's go through a summary and check of the spec. All right, this is really important. You want to make sure you're going through the specification yourself, checking that you know everything you need to. So we went through the structure of acid anhydrides. We did that. Acyl chlorides, we did that. And amines, okay, just going over amines again real quick. C-O-N-R, R prime, and then this can be an R group, okay? And this right here, this is the amide linkage, okay? The C-O-N. All right, that's our amide linkage right there. Next up, we need to know the nucleophilic addition-elimination reactions of acyl chlorides and acid anhydrides with water, alcohol, ammonia, and primary amines. We went through the conditions, the reagents, and the starting and ending functional groups. In terms of the mechanism itself, as I mentioned, I'm saving that for another video, but we went through every single thing you need to know for each of these 4 reagents, okay? So hopefully that was helpful. If it was, smash the like button, subscribe for future content just like this. Comment any questions down below. Best of luck in your revision and upcoming exams, guys. Until next time, peace.